At 7:46 in the evening on July 31st, 2026, the ground beneath one of Europe's most closely watched volcanic systems shook harder than it had in 40 years. A magnitude 4.7 earthquake struck the Campi Flegrei caldera just west of Naples, Italy, its epicenter sitting almost directly beneath the Solfatara crater in the town of Pozzuoli. Italy's National Institute of Geophysics and Volcanology, known as INGV, confirmed it as the strongest earthquake recorded in the area since continuous instrumental monitoring began. 21 people were injured, 2 of them seriously. Buildings were damaged. Rail and metro service across Naples was suspended. The port of Pozzuoli closed, cutting ferry service to the islands of Procida and Ischia. This wasn't an isolated event. It's the latest and strongest entry in a pattern of unrest that scientists have been tracking here for over 2 decades. Campi Flegrei is a caldera, a vast, mostly collapsed volcanic depression roughly 9 kilometers west of Naples and about 50 kilometers from Mount Vesuvius. Unlike Vesuvius, which rises as a single recognizable peak, Campi Flegrei's structure is far less obvious from ground level, an outer caldera roughly 12 kilometers across, with a nested inner caldera and multiple smaller collapsed structures layered within it, much of it now sitting beneath the Bay of Pozzuoli itself. Italian geologists and volcanologists classify it as a supervolcano, a term reserved for systems capable of producing eruptions large enough to eject more than 100 cubic kilometers of material at once. Campi Flegrei's deep history includes exactly that scale of event, the Campanian ignimbrite eruption roughly 39,000 years ago, and the Neapolitan yellow tuff eruption around 15,000 years ago, both among the largest volcanic events in European history. Its most recent eruption, by contrast, was comparatively small, the formation of Monte Nuovo in 1538, and nothing has erupted here since. The mechanism driving Campi Flegrei's current unrest is called bradyseism, a genuine, well-documented geological process in which the ground surface slowly rises or falls as fluids and gases shift beneath it. Since the current phase of unrest began around 2005, the ground near Pozzuoli has risen by more than 140 centimeters, with INGV currently tracking an uplift rate of roughly 10 millimeters per month. That uplift isn't uniform or constant. It has accelerated and paused in phases over the past 2 decades, but the overall trend has been a sustained rise, accompanied by increasing seismicity and shifting gas emissions from the area's fumaroles, most visibly at Solfatara, where sulfur-rich gas has vented from the ground for centuries. According to INGV's own published research, the volcanic system has been sitting beneath a natural cap rock, a layer of rock and sealed sediment that has historically helped contain pressure from the hydrothermal system below. As seismicity and pressure have increased, this cap rock has become progressively more fractured, and that fracturing is a large part of why increasingly larger earthquakes have become more frequent in this specific area over the past several years. To put July 31st's magnitude 4.7 in context, the strongest events recorded here previously were 2 magnitude 4.6 earthquakes in 2025. This new event doesn't just edge past that record, thanks to how earthquake magnitude scales. A magnitude 4.7 releases roughly 3 times more energy than a magnitude 4.4, and meaningfully more than the 4.6 events that came before it. The shallow depth, roughly 3 kilometers below the surface, is a major reason the shaking caused as much damage as it did. Earthquakes at this depth deliver their energy close to the surface, with far less rock to absorb and dampen the shaking before it reaches buildings and infrastructure above. A magnitude 3.8 aftershock followed roughly 2 hours later in the Gulf of Pozzuoli, part of a broader swarm of more than 30 recorded tremors that evening, with additional shocks reaching up to magnitude 3.1. It's worth being precise about what this earthquake does and doesn't tell scientists about the likelihood of a future eruption, because that distinction matters enormously for understanding this story accurately. Earthquake activity at Campi Flegrei is overwhelmingly attributed to hydrothermal processes, superheated fluids and gases moving through fractured rock in the upper few kilometers of crust, rather than magma itself moving toward the surface. That doesn't mean the earthquakes are disconnected from the volcano's deeper behavior. The same pressure changes driving bradyseism are what's fracturing the cap rock and generating this increasing seismicity in the first place. But INGV has been explicit and consistent in its public communications that increased seismicity and ground deformation, even at this scale, does not by itself indicate that an eruption is imminent. Volcanic unrest of this kind can continue for years or even decades without ever escalating into an eruption, and Campi Flegrei itself experienced a comparable, though smaller, crisis of uplift and seismicity in the early 1980s that eventually subsided without an eruption. That said, the current phase of unrest is genuinely different in scale from what happened in the 1980s. Seismicity and ground deformation at Campi Flegrei have been on a general upward trend since roughly 2005, and that trend accelerated sharply starting around 2020. The area has recorded multiple magnitude 4 or greater earthquakes across 2024, 2025, and now 2026, a pattern of recurring strengthening events that INGV's monitoring network has documented closely. Italy's Department of Civil Protection has maintained Campi Flegrei at an elevated alert level for several years, specifically because of this sustained trend. And the government has already begun structural safety assessments of buildings in the area, with Italy's Deputy Prime Minister publicly committing to assistance for displaced residents and a longer-term plan for redeveloping and securing buildings that inspections have found unsafe. This matters enormously because Campi Flegrei isn't some remote, uninhabited volcanic field. Tens of thousands of people live directly within the caldera in Pozzuoli and surrounding communities, with the greater Naples metropolitan area, home to roughly 3 million people sitting immediately adjacent. Unlike a more isolated volcanic system where unrest primarily raises scientific questions, ground shaking and structural damage at Campi Flegrei is already a direct present hazard for a large population, independent of any future eruption risk entirely. The building collapse risk from earthquakes like this one is compounded by the fact that much of Pozzuoli's older architecture wasn't constructed to modern seismic standards, and it sits directly on the same volcanic tuff rock that has been repeatedly fractured by decades of accumulating seismic activity. Campi Flegrei also isn't operating in isolation within Italy's broader volcanic picture. It sits along the Campanian volcanic arc, part of the complex tectonic boundary where the African plate is being forced beneath the Eurasian plate, the same broad system responsible for Mount Etna in Sicily and Marsilli, a large submarine volcano in the Tyrrhenian Sea that remains comparatively understudied given its size. Etna itself has been highly active in recent days, sending ash columns several kilometers into the atmosphere and producing lava flows, activity being tracked independently by Italian volcanologists as part of the country's broader monitoring network, though INGV has not attributed any direct causal link between Etna's activity and the Campi Flegrei earthquake specifically. Distinct volcanic systems separated by hundreds of kilometers along the same general tectonic boundary. It helps to understand how Campi Flegrei compares to other well-known caldera systems, because the term supervolcano tends to conjure a single dramatic image that doesn't always match how these systems actually behave. Yellowstone, in the United States, is probably the most widely recognized comparison. A similarly large caldera system with its own history of monitored ground deformation and periodic seismic swarms, where United States Geological Survey scientists have consistently emphasized that unrest, uplift, seismicity, gas emission changes does not reliably predict eruption timing on any short horizon. The same caution applies at Campi Flegrei. What makes these systems genuinely difficult to forecast isn't a lack of monitoring data. Both Yellowstone and Campi Flegrei sit among the most heavily instrumented volcanic systems on the planet. It's that caldera volcanism operates on timescales and through subsurface processes that don't translate cleanly into the kind of short-term warning signs scientists can identify at more conventional stratovolcanoes like Etna or Mount St. Helens, where magma typically has to travel a more direct, more easily monitored path toward the surface. Campi Flegrei's own history includes a genuinely useful precedent for understanding the current situation, the seismic crisis of the early 1980s. Between roughly 1982 and 1984, the area experienced a significant episode of ground uplift and increased seismicity, serious enough that authorities evacuated portions of Pozzuoli at the time as a precaution. That crisis eventually subsided without an eruption, and the ground even underwent a period of partial subsidence afterward, before the current, longer-running phase of uplift began around 2005. Scientists studying the current unrest have been explicit that the cumulative seismic energy and deformation recorded since 2020 already exceeds what was recorded during that entire 1980s crisis. A genuinely significant comparison, though one that still doesn't translate into a specific prediction about whether or when this current phase might follow a similar pattern of eventually subsiding or instead continue escalating further. The honest scientific position is that nobody currently has a reliable way to determine which outcome is more likely from the data available so far. If you're the kind of person who wants to understand exactly what monitoring agencies are actually watching for, rather than just reacting to another alarming headline, that's exactly the kind of coverage this channel focuses on. So consider subscribing if this breakdown has been useful. Here's what INGV and Italian civil protection authorities are specifically monitoring in the aftermath of this earthquake, and what would represent a genuine escalation versus continued, manageable unrest. The first thing scientists track closely is the aftershock pattern itself. Specifically, whether seismic energy stays concentrated in the immediate area around Solfatara, where the bulk of recent activity has centered, or begins spreading to previously quieter sections of the caldera. The second is any measurable change in the rate of ground uplift, since a sudden acceleration in bradyseism beyond the current roughly 10 millimeter per month rate would represent a genuinely significant shift in the system's behavior. The third is gas composition and emission rates from the fumarole fields, since changes in the ratio of specific gases, along with rising fumarole temperatures, can indicate shifts in how fluids are circulating through the hydrothermal system at depth. Italy has direct, recent experience with the practical danger of shifting gas emissions here. Fumarole activity near a local school forced its closure earlier this year after gas levels became a genuine safety concern. A reminder that hydrothermal hazards at Campi Flegrei extend beyond earthquake damage alone. INGV's continuous monitoring network, one of the densest volcanic monitoring systems in the world, is specifically built to catch exactly these kinds of shifts as early as possible. It's also worth understanding how Italian authorities currently frame the actual eruption risk here, since that's a different and more carefully bounded question than the earthquake risk itself. Official Italian volcanic hazard assessments describe a genuine eruption at Campi Flegrei as a low probability event on any short time horizon, even accounting for the sustained increase in seismic and deformation activity, precisely because volcanic systems of this size and complexity typically show unrest for extended periods, sometimes many years, without that unrest necessarily culminating in an eruption. What has changed is that Italian civil protection planning has grown considerably more serious in recent years, specifically because of this sustained trend, including expanded evacuation planning for the roughly 500,000 people living within the broader Campi Flegrei red zone, a designation based on historical eruption modeling rather than any specific prediction of imminent activity. It's also worth understanding how scientists actually study what's happening deep beneath Campi Flegrei, since the hydrothermal system driving all of this activity sits well below what anyone could directly observe. INGV maintains one of the densest seismic monitoring networks anywhere in the world, specifically within this caldera. Dozens of seismometers, GPS stations, tracking ground deformation to millimeter precision, and continuous gas sampling equipment positioned around solfataras and other fumarole fields. Beyond direct monitoring, researchers use a technique called seismic tomography, essentially using the way earthquake waves travel through different rock types at different speeds to build a three-dimensional picture of what's happening underground. Similar in principle to how a medical CT scan builds an image from X-rays, passing through tissue at different densities. This technique is what allowed scientists to identify and map the cap rock structure sitting above the hydrothermal system, and to track how consistently that structure has been fracturing over the recent years of increased seismicity. Combined with resistivity surveys, which measure how easily electrical current passes through different underground materials and can help distinguish fluid-saturated rock from drier surrounding material, this gives researchers a genuinely detailed, continuously updated picture of the system's internal structure, even though nobody can physically observe what's happening several kilometers beneath Pozzuoli directly. For residents of Pozzuoli and the surrounding area, this earthquake represents a genuine immediate hazard, independent of any longer-term volcanic questions, structural damage, injuries, and the disruption of transportation and essential services are all real, current consequences that don't require an eruption to matter. For the broader scientific and public safety picture, this event adds another data point to a trend Italian authorities have been tracking closely for years: sustained ground uplift, increasing seismicity, and a genuinely fracturing hydrothermal cap rock, monitored continuously by one of the most sophisticated volcanic observation networks in the world, specifically because of what happens here. We'll continue following developments at Campi Flegrei as INGV's monitoring data comes in over the coming days and weeks. Thank you for watching, and I'll see you in the next one.